Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to calculate the standard free energy change in a chemical reaction, but this is the third method. So the first method was using the equation where you can calculate the standard free energy change of a reaction by taking the enthalpy change, the standard enthalpy change of a reaction, and subtracting the product of the temperature in Kelvin multiplied by the standard entropy change of a reaction. The second method was to use just tabulated free energy of formation and use the equation where the sum of the products, the sum of the standard entropies of formation, the standard free energies of formation multiplied by their stoichiometric coefficients of the balanced equation, and subtracting from that the sum of the reactants, the sum of the free energy of formation of the reactants multiplied by their stoichiometric coefficients of the balanced equation. In this video, I'm going to be going over method 3, which is basically we're using Hess's law. So that is that for a stepwise reaction, if you have some reactions that will add up to another reaction, right? So if you add reactions together to get another reaction, then you can calculate the delta G, or the standard free energy of reaction, from the changes in the free energies of each step, right? So just like we had done that for the enthalpy of the standard enthalpy changes of a reaction, right? So if you have certain reactions that when you add them up together, they add up to another reaction, you can add up the enthalpies of the individual steps to get the final total enthalpy change of the reaction. You can do the same thing for free energy changes. So just as we can calculate the standard enthalpy change of a reaction from the enthalpies of each step, right? If we have a stepwise way of getting to the final product using, again, that's Hess's law, we can do the same for our standard free energy change of a reaction. So to remind ourselves from what we saw before with enthalpy, right? So the same applies to free energy changes. So if a chemical equation is multiplied by some factor, then the delta G, the free energy change of the reaction, is also measured by that same factor. We saw this with enthalpy changes as well. So number 2, if a chemical equation is reversed, then the free energy change of the reaction is going to change signs. So if it was positive, it becomes negative. If it was negative, it becomes positive. And again, we saw that with the change in the enthalpy of a reaction as well. And third, if a chemical equation can be expressed as a sum of series of steps of other equations, right, then the delta G, or the standard, the free energy change of the reaction for the overall equation, is going to be the sum or the addition of the free energy changes of the reactions for each step. So if you have a bunch of steps, reactions that are steps that add up to a final reaction, then the free energy changes of the individual steps will add up to the free energy change of the overall reaction that you get from adding those reactions together. So that's the third method. And in another video, I will show you how you can use that third method. But this is the third method according to what I have discussed. So I hope this was helpful. I hope you found this interesting. If you like this video, please hit that like button, share the video, please. Subscribe to my channel, hit that notification bell right up there. And so that way you can be notified by other videos that I put out. Put a comment down there in the comment section below. let me know what you think. And if you've got any questions, I would love to hear from you. Thanks for joining me and have a great day.